Okay, this is the superposition theorem application. So here we have the network, and we are going to calculate the I naught using the superposition theorem. So this is one of the example with the dependent source. Now first step is we have to remove the 20 volt source, or we can also remove the 4 ampere volt 4 ampere current source. Whichever source you remove, it doesn't matter, but you should remove only one source at a time. Now in my solution here, I am removing the 20 volt. So when I removing the 20 volt, I'm going to short circuit this voltage source to make it 0, and this is my new circuit diagram. So initially I had a voltage source here, and then now I have shorted this. So after this, now you have to apply the circuit analyzing technique. In this case, I have applied the mesh analysis. So when I apply the mesh analysis, again you have here the super mesh case 1, where current source is at one of the mesh. So from this we can directly calculate the I1, which is equal to 4 ampere. And then at mesh 2, at this mesh, again I'm going to frame the equation, and then I got the equation like this. So this equation, so 5 ohm of I2 minus I1 plus 1 ohm of I2 minus I3. This is the 1 ohm, and then I have I2 minus I3 plus this voltage source, but this voltage source is being controlled by the current source at this. So just now I'm simply writing it as 5 I naught plus 4 times the I2. Okay, so you will have equation 0. But from here, from this branch, we know that I naught is equal to I1 minus I2. So after substituting the value of I naught in this here, so we got the equation like this. So this is our first equation. And at mesh 3, again at this mesh, again if we apply the KVL, so it will be 2 of I3 minus 5 I naught plus 1 of I3 minus I2 plus 3 of I3 minus I1 should be equal to 0. Again you have to substitute the value of I naught and then simplify that one. So when you simplify this one, I got this equation, and from here I can solve for I1, I2 and I3. And as per our requirement, we need to calculate the I naught. So I naught is given by I1 minus I2. So we got the I2, and we already have I1, which is equal to 4 ampere. So in order to calculate, let's keep this one as I naught dash. So here is given as I naught dash, which is equal to 1 minus I1 minus I2. So you get 3.059 ampere. And now the second step is we have to remove the 4 ampere current source. Now in order to remove the 4 ampere current source, we have to open circuit it. So remember, for the current source we have to open circuit, and for the for the voltage source we have to short circuit it. Now when you remove the current source, so this is how we have in our simplified circuit diagram. Now again we are applying the mesh analysis, and then we have the first equation here. Okay, first equation. So how we got this first equation? Simply apply the KVL. So negative 20 volt plus 5 of I1, okay, plus 1 times I1 minus I2 plus 5 of I naught, okay, plus 4 I1. So our I naught is this, but here they have taken as I naught double dash. So let's also take this one as I naught double dash. So when you substitute that I naught double dash is equal to negative of I1, then we have this equation. This is our first equation. And then add mesh 2. Now we are again talking into this mesh. So it will be 2 of I2 minus 5 of I naught double dash plus 1 of I2 minus I1 plus 3 of I2 is equal to 0. Again, when you substitute this one, I naught double dash as negative I1, then you will get a simplified equation like this. So again, after solving equation 1 and 2, you will get the I naught double dash as this one. Now as per the superposition theorem, it is the sum of the current which is given by the individual source. So from the 4 ampere source, we got I naught is equal to this value, and from the 20 volt source, voltage source, we got I naught is this one. So our final I naught is minus 0.470 ampere. So that's all about the superposition theorem.